Thank you. Hello, everyone. First of all, thank you for joining. Uh, so my name is Gurupreet Singh, and I'm a developer, data engineer at Google. Been working with material design and Jetpack Compose teams to make beautiful Android apps. And today we're going to learn about making adaptive apps with Compose and Material. But before we jump into making apps adaptive, let's see what is adaptive. Well, this is a good example of adaptive. No, seriously, so adaptive is when your app UI is responsive to account for different screen sizes, orientation, states, and also utilize those screen available area for better user experience and accessible navigation and ergonomics. But why suddenly we should care for adaptive? We have been making apps for 10 years, and many of us are making apps since Android 1, and we didn't care at that time. Well, now more than ever, we have so many different size devices running our apps. We have phones, tablets, foldables, desktop, all can run Android apps now. And to provide the good experience on all devices, we should try to make our apps as adaptive as possible. Now we know what is adaptive and why should we care. Let's see what are the tools at our disposal to help us. Google's material new design system has mainly focused on the personalization and experience. So adaptive and accessible design has been key part of the material 3, which we can see that material 3 already is giving adaptive first guidance for small fonts, large displays, and covering all of them. Also, at the same time, it also covers design implementation and guidance on foldable or flexible displays. It also provides a canonical layout guidance, which is ready to use placement slot method for us to imagine how we can tackle the future of different design or device orientation and sizes. It helps us to rethink the layout in a new way. We can think of layout as a building block of different region covering key aspect of the applications. We just now not just think of a feature or anything. We think of layout as like a navigation area, app bar area, and body area, which can be used to place slots in the application. So you do not worry about what is your screen size, but you just worry about where you're going to place these slots when the screen size changes. And similarly, we can take body to the further next steps and segment into the different area, list and detail, or you can call it single or dual pane areas, which we can decide to show or hide depending on the screen sizes available. Now we checked how material design has laid foundation for teaching us like how adaptive apps can be made. Let's see how our favorite Compose is also adaptive friendly. Compose is Google's suggested way to make future apps on Android, and it also helps us making apps for large screen very easy. Since Compose is declarative to start with, it's super easy to just write simple code and if-else loops to make adaptive layouts. Compose is also stateful, so whenever the screen state changes in this example, it will automatically adapt to the grid view or list view depending on the current state, instead of us evoking the new states setup again. Compose is not using any layout XML for designing the UI and saving us a lot of work of maintaining multiple layout files for different screen sizes and orientation, which has been growing with time. Now we've seen that what we have for our disposal in the tools like Material and Android and Compose helping us to make adaptive app, how we can get started and make our current app adaptive. Let's take a look at this reprise sample, which is an adaptive Compose sample built using Material 3 and Compose, and how we can use simple steps to make our app the existing app adaptive from learning from this. We can see it covers multiple screen sizes from mobile, tablet, large screen, a different kind of material navigation components, and also different responses in single or dual pane of the body. To start thinking about which navigation pane to use or which screen size to use or how many display panes to use, we first need to deal with what are the screen sizes we are dealing with. Now we have many different screen sizes with multiple app modes, with app inside laptops running, and we cannot just rely on the physical size that we have from configuration. Physical size may not always correspond to the size our app is running. As you can see here, if our app is just running in the blue area, we cannot decide our navigation or the content area, body area, just depending on the display size. We need to know the portion of the screen size that our app is using. So let's look into it. The preferred way to determine the screen area our app is using, we can use Jetpack's window manager library, which provide with window matrix calculator. So it gives us the maximum window matrix and the current window matrix. If I'm on a large tablet, just for example, but app is used in a multi-window mode, then it doesn't matter how big the tablet screen is. What's relevant is the space available to my app in the given time. So we'll be more focusing on what space that our app is taking than actually thinking about the device configuration size. Now we have this dimension and size. We are worrying about that how much our app is taking, but those dimensions are just numbers. We want to put them and classify them to a breakpoints which we can make sense, so that we can divide them in a way that our designs and the code can understand. We can use window and height width classifications. In window width classification, that's probably the most relevant values for most apps due to vertical scrolling of height. And these breakpoints partition common devices type, give them names, which can give us common language for both design and implementation. A compact width window corresponds to a phone, a portrait mode with a width less than 600 dp. A medium window size corresponds to a tablet or inner display of a foldable in portrait mode with the window size between 600 to 840. And finally, an expanded with the correspond to tablets or large tablets or even laptops running Android applications. Similarly, we have window height classes for providing compact, medium, and expanded window height. We will see later how it can helps us to improve user experience, but now we mainly focus on window width to make our app adaptive to this. So now to get the real-time window size information, we can use materials window size library for Compose to access this partition, which we just saw. It exposes us a method called calculate window size, which we can observe and pass it down to our app's composable entry point. So now now our app is able to observe the window size. We need to set up how our app content reacts to it. Similarly, we saw how our layouts are designed. We will think of, we will mainly focus on navigation and body areas to adapt, which itself will make our whole layout respond to different screen sizes. So let's start with navigation. Material navigation already provides a suite of different navigation components that's designed and implemented to fulfill the different screen size needs. We have bottom navigation we all use in phones. We have navigation rail for medium to large devices, and we have navigation drawer for very large tablets or foldables. Let's try to make a variable that is navigation type, which can help us devise our navigation of the app dynamically. For compact windows, we will go with the bottom navigation, and for the medium size, we are using navigation rail here, and for the expanded size, we will go with the permanent navigation, which can help us cover all the cases for different kind of navigation. Now we have our navigation setup. We can focus on our body, which we can again divide into two panes, which will first pane shows our main content, which should always be there because that's the part of the body, and other content can be used when we have enough space or extra information to show. Similarly to the navigation type, we can now have our content type for our body. So for both compact and medium, we choose single pane. If we want to show different pane for medium size, we can also divide different layout. And for expanded, we just go with dual pane because we want to show more information only when we are very larger screen. Now we have both content and navigation type variables tied to our window size observer. We can see how we can leverage it to make our app content dynamic. To make our app dynamic in a simple steps, we can first decide the navigation type of our app. Taking advantage of Compose declarative structure, we can write the navigation type is rail or drawer, and we place either of them in a row fashion. Then at the bottom, if our navigation is bottom navigation, we will place it at the bottom of the column at last, and we will add our body to the correct placement. And here we are passing our content type to the body because our body will still wants to react to the different kind of content. We are always showing our main list view of emails or email information or list view that will always be there. But when the content type is dual pane, we want to simply add this to show our detail screen next to our list screen in a row fashion. That's where the Compose actually shines. It's make it super simple to make our layouts responsive. Now we have put together this navigation and content that reacts to different screen sizes. It's already very good to make our app looks good on different screens. We can further enhance this experience by targeting foldables. Foldables are also on a rising number of devices with different kind of folds available in market. Before we jump into foldables, we should understand the feature they come with. We need to consider what kind of devices we are dealing with. So features help us understand what is the current state of foldable device, and it can go to many fold states. State tell us if the fold is opened, half opened, or normal. Similarly, orientation tell us about the both device and hinge orientation, which can later help us decide different type of posture the fold has. The occlusion type tells us if there is some physical hinge or stage or area where the user is not able to see the UI, so we should not place any touchable content there. We can also use separating, which actually tells us if there's a one fold that's separating using a physical hinge or a crease or a connector, so that we can avoid that area to place our UI content, which can be interacted by the user. Now we know this, let's jump into how we can make our app aware of these fold features. We can use Jetpack's window manager, which actually gives us a window info tracker, which is a very nice interface that provide the layout info, not just the fold info, but we are here just interested in the main fold info. And we will collect it, which will give us the stream of layout information that helps us make a real-time decision on the base of what we are, what stage or is the foldable is in. Now we use this layout info's display feature to get information about the fold feature we just checked. But these are just feature like width, height, orientation, fold state. We want to classify them in a sensible fashion so we can just make our app uh, fit in all those scenarios. So we can just say we have this classification of fold features, which is just the postures. The device can be in a book posture, it can be in a tabletop posture here, and it can be fully open or fully flat. And it can be separating also where there's a physical hinge in the middle that will always be there. Now let's see how these fold features we can implement in our app. So now where we passed the window size in our composable, we will also pass device posture. Device posture and window size are now observable to our content, and our content can react to it. We saw we added navigation for expanded stage to be permanent navigation drawer always. But now if we detect our device is in a book posture, we do not want to do that because that permanent navigation drawer may push our main content of first pane in the middle of the crease or the hinge. Similarly, we can actually detect the hinge if there is a book posture or a separating hinge. We can go for dual pane or and instead of single pane, which we were choosing in medium size. Here it still looks a bit cramped, so please consider your UI in a way that you're designing that if the foldable has a crease, how you want to handle and decide to go for single lane or dual lane. Now we know there are can be very physical hinge like Surface Duo that are actually placed in the middle of the content. So we do not want to have the content there that's not visible to our users. To do that, we will have a check if there's a separating, we will have our custom hinge spacer, which can be get from the device posture to separate our content accordingly the hinge. So now our app is even better and it's understanding that if there's a fold in the middle, it will separate the content, it will keep the navigation correct, it will keep the spacing correct. And that's how we are just improving our user experience for all the users who are using foldables and different kind of screen states. And user experience is very important, especially for cases when we have different type of devices user expects. We added the user, improved the user experience for small, medium, and large devices, but we can further improve it to make it even more impact to our users. Let's see some of the points that will even enhance the more user accessibility and experience. We can see continuity. Continuity is very important to user when your app is used in different scenarios, in multi-app mode, inside a window, and that can resize the app. So you can use few of the following steps to make sure that your app is continuous during going through all these phases. You can always provide your UI states flows with the view model that actually runs outside the configuration changes. So if you have a scroll state or a selected state of an element that's given by the view model, it will survive the different changes and will not cause any disruption to the users. Similarly, you can actually handle configuration changes in some cases where some foldable or some tablets, when open or closed, they do cause configuration changes. You want to keep the state of the users intact. If the user is typing something in the text field or they are dragging some item, you want to make sure that it's still intact and still selected when they change the fold state. You can also use Compose Remember and Remember Savable, which actually provide a lot of good features like remembering the scroll state of the device when it's going from fold to unfold or when it's being stretched to a larger screen. So this Remember and Remember Savable will both provide us the information we need to keep the way our current state was. There are a few other advanced API also, which is movable content of, which we will be coming up in next Compose release, which will try to make our app very static, the content very static as compared to whatever moves around it. We also want to care about the ergonomics of the device. We have now devices very big, very small, very heavy. We do not want to put pressure on the user. So here you can see we have 1, 2, and 3 points where when user is holding the point, even though one is reachable, but user may have to spread its fingers to reach there. And 3 is the point which can be easily clickable if the user is holding the device from there. So we know that the 2 is our optimal place to put our information that we really want users to interact with. Similarly, we had navigation rail where we can put it to top, bottom, or the middle. But now we see the device sizes. If the device or tablet is very long, we really want to put it at the bottom so user can interact with it. But a device is a medium size where user is holding it with their thumbs. it should be in the middle. And if the device is very small, so it's all right to put it at the top as well. We just learned about the window height size classes, which we didn't use actually. So now we can see that we can decide the navigation rail alignment to depend on the window height classes. We can see if it's a compact height, we can use top alignment. If it's a medium height, we can use center alignment. And if it's a expanded height, we want to align it to the bottom. Now to recap it, we target the foldable features, we understand the fold classifications, and it's keep on growing as well. Using fold postures and hinge position in our app, and app continuity and ergonomics for better user experience. This all small steps has helped to improve the user experience, accessibility, and ergonomics of the using a large devices so that user feel very comfortable when they are using your app on large devices. We have covers many cases and showcase power of making adaptive apps that help user. And you can check this sample, which is part of official Compose samples, or you can go to this link to try this sample out if you have tablets, foldables, and large devices. And this space is ever growing. We are seeing a lot of new devices coming, a lot of new screen form factors coming. So this sample will be our first guidance to provide the adaptable information to our users. We will be continue developing it to give more information as we have more and more device states and screen orientations coming. You can go to more resources here that covers the adaptive guidance and adaptive code lab as well, along with the developer.android.com large screen guidance, which actually tries to teach you how to make your Android app both for Android and Compose for the large screens. Thank you. That's all from my side. And you can follow me on Twitter or GitHub. I do a lot of work on Compose Cookbook and other Compose samples as well. So I will be sharing a lot of that information that in my Twitter or GitHub as well. Thank you, everyone.
Thanks, Gurupreet. Thanks for taking out the time. And it's really interesting to see because we are seeing devices also with various form factors. And when we see the software that's or APIs from Compose matching that to build various UIs, it's really interesting to see that. So thanks for taking out the time and taking us through the various resources and the guidelines around building UIs. I think we have several questions, so we can go through them one by one. So if you can open up the Q&A section in the panel, we can take one at a time.
Okay. How would you create adaptive layout to handle large font size with smaller screens? The typography is also one of the key improved part of new material design system. So do look at into the typography guidance at material design. It provides you information about how you can leverage actually different typography depending on as the screen size increases. If you are a very large tablet, you can actually use a different font structure as compared to if you're using on a mobile. And I think it will be nice that if you are using a small devices and with a very large font, which is very good for accessibility, you make sure that your app actually using all the expandable components that do not cut out any of the informations. Most of the material components has been actually tested a lot on the accessible range. For example, bottom navigation, the navigation drawer and navigation rail has text information which actually grows with the with the font size, but to a certain limit to reach the accessibility levels. What is the minimum API for these new window libraries? Window, if the reply sample is already working with a minimum of 23 SDK level, and these APIs are very stable and also available for both Compose and Android views as well. So it's not just limited to the Compose. So you can use it right outside the window, and it provides very good information about how your app is running in and around environment now, especially when Windows Phone, Chrome OS, Windows laptop, and Chrome laptops are able to run Android devices. It's we cannot rely on the configuration sizes anymore. We really need to know how much screen size our app is actually taking to make those decisions. How one should approach RTL for some language while building adaptive layout. I think if you notice, even the navigation rail, we use the start and or we have been using all the information that actually is RTL supported. All the compose components, the material components are RTL supported. So it should be supported out of the box if you're using the correct information. Avoid to use left, right alignment or left or right as a constant to break your app during the article.
Awesome. Thanks.
Thank you.
I think we have two more questions.
Okay, let me check.
Yeah.
Oh, what emulator support do you have? Uh, the first of all, if you go to this Adaptive Compose Code Lab, which is part of the resources, let me just resources, you can see it actually highlights the emulator that came with the Android Studio. I think Android Studio is still in Canary, but you can check, and it covers that you can use it adaptive size tablet where you can test your app for mobile, for large screen, for medium screen, and yeah, foldable as well. Is this meant to have a complete replacement for fragments? Uh, Fragments, this was completely covering in Compose, so where we are recommending to develop complete new apps using fully Compose. But if you have existing apps that's using fragment, I think the Compose itself has a guide how to use fragments in Compose. I think that would be better suitable for those scenarios, but it built using most of the composable, which is very flexible to use and make adaptive. Thank you.
Awesome. Thanks for answering all the questions. Just a follow-up question that I asked about the right to left layout. So let's say if user selected any language, which is right to left, does it adapt layout-wise also? So let's say I have a main screen and the detail screen. So detail would be on the left-hand side and the main on the right-hand side, or just the content?
Yeah, I think what I meant by was the content, because
I
we
see.
are using the our own custom placement of the structure.
I
But
see.
I think you can use either. I need to check on this. I'm not sure if the row of compose actually take care of RTL. It should. If it does not, then you have to check for the RTL and realign the components. But I do think the row element should take care of the RTL itself.